Welcome to the Calculus C section. In this section, we'll be discussing polar coordinates. So up until this point, your math career... Welcome to the Calculus C section. In this section, we'll be discussing polar coordinates. So up until this point in your math career, you've only dealt with a rectangular or Cartesian coordinate system. However, this will no longer be the case. As we progress further and further through math, the XY coordinate system is not always the easiest or most efficient way to work. Therefore, in this scenario, we will use the polar coordinate system to make work more efficient and problems more manageable. So in order to understand a new coordinate system, we must define a coordinate system. Well, a coordinate system can be defined by a mannerism or a way to define a point in space. So in the rectangular coordinate system, we use x to indicate the horizontal space that a point occupies, and y to indicate a vertical space that a space occupies, giving a point an x, y location. However, with polar coordinates, what we do is we say that how far away is something from its radius, and at what angle does it differ. So the origin is going to be our center point, and we are saying, okay, this point is this far away from the radius, and it is at this angle. So this will be our r, this will be our theta. So if we had a point and we wanted to measure where a ball was being thrown, we can say, oh, that's at x equals, x equals r cosine theta, and someone can say, oh, and it reached a maximum height of y equals r sine theta. So these are our little conversions for polar coordinates, because we could say it reaches this distance per se, and we're saying we want to find out how high it goes, so we say opposite hypotenuse, and we know our hypotenuse is r, and we know that our opposite is y, so we can say y equals r sine theta. And we want to say, oh, it went out this far from the origin, so we can say that we want to use cosine, which is adjacent hypotenuse, and we'll say the x and hypotenuse is r. So that kind of just lays the basis for what, or how we convert between polar coordinates and why we use polar coordinates. So it's important to understand that polar coordinates plane r can never be negative. The only time we use a negative r is because we're just indicating its position in space. We can't have a negative radius in a circle. All we're saying is, instead of it being in this plane, maybe it's in the third quadrant, maybe it's in the fourth quadrant, maybe, let's say we were a guy and we were throwing a ball, and instead of it landing forward in this direction, we accidentally slip and fall and it lands back here. Well, the distance per se isn't negative. It's still away from the person, but the direction is not the same direction that we indicated that we wanted to throw. So maybe we can say that this point is a negative point on the plane, but it's not actually a negative value, which is a similar idea for how we indicate radius. So I hope that helps you visualize polar coordinates and understand polar coordinates. There's a bunch of problems on the website, and if you need more assistance, that is on the website as well. I hope that helps. Thank you.